The next part that we are going to do is identify the truth value of conditional statements. So the first two are going to be pretty easy for us to understand, I think. The next ones, they're going to be a little interesting. They're going to be an interesting case for us. So the first part, if I say that my hypothesis is true and my conclusion is true, we would probably and hopefully understand that my conditional would be true. Okay, the next one. If I would say that my hypothesis is true and my conclusion is false, then we're going to say that my conditional is false. The whole thing is going to be false. So if the hypothesis is met, but the conclusion is not, that means we have a false conditional. The next two, that's these ones right here. If my hypothesis is false, we cannot determine the truth value of the conditional very well. So all we're going to do in this case, whenever your hypothesis is false, so both of these cases, the hypothesis is false, these can be changed however they want to be. It's not going to matter. Whenever this case happens, hypothesis is false, we're going to take our conditional to be true. And those are the two cases that people get mixed up on. We just cannot determine the truth value of it, so we're just going to say that the conditional is going to be true when the hypothesis is false. We're going to do 3 examples out of this. Hopefully it'll make sense here in a second. So I want to start with letter B. Okay, it says determine the truth value of each conditional statement. If true, explain your reasoning. If false, give a counterexample. The counterexample, if it is false, is pretty important to me. So letter B, if next month is August, then this month is July. Well, it's saying if we're in July, then it is August. You may flip those if you need to. That is a true conditional. The hypothesis is true, then the conclusion is true. Therefore, the conditional is true. If we jump back to letter A, it says if you divide an integer by another integer. Integers are numbers like -2, -1, 0, 1, 2. You can go off in both directions. If I would divide 2 of those numbers together, then I would also get an integer. So I would get a number just like that. Well, this is a false conditional. I can certainly divide an integer by another integer. That's a true hypothesis. However, the conclusion is false. Just because I divide 2 numbers does not mean I will get another integer out of it. Let's take, for example, 2 divided by 3. Well, 2 divided by 3 is really the same thing as 2/3, which is a fraction. That fraction does not look like any of these numbers over here. So you would say that that is a false conditional. And then finally, letter C. If a triangle has 4 sides, then it is concave. Okay, this goes back to the previous slide. If our conditional, or if our hypothesis is false, then our conditional is true. A triangle does not have 4 sides. It has 3 sides, which means that our hypothesis is false. Since our hypothesis is false, our conditional is true. We cannot determine its truth value, so we're going to say that it is true.